Right, hello. I am going to be showing you how to do chapter 8 of the year 1 AS core textbook on chapter 8, the binomial expansion. So we're going to be learning a lot about Renior Binomial mathematics. If you want to learn more about Renior Binomial, very famous 16th century mathematician, you can ask your maths teacher. He's an interesting chap. So first thing we're going to do is look at expanding brackets, which is what this is really all about. So if we take a plus b to the power of 1, well, that's just a plus b, obviously. Then what about a plus b squared, which is a plus b times a plus b? Well, there are a variety of methods for expanding brackets. We'll use my preferred method, which is the box method. So we have a plus b times a plus b, giving us a squared, ab, b squared. Adding down the diagonal, that gives us a squared plus 2ab plus b squared. Okay, now let's go for a plus b cubed, which is a plus b times a plus b squared, which is a plus b times by our last result, a squared 2ab b squared. So again, going for a box method, that's a plus b times a squared plus 2ab plus b squared, a cubed, 2a squared b, ab squared, a squared b, 2a squared b, b cubed. Added our diagonals gives us a cubed, 2a squared b, plus 2ab squared, plus b cubed. And we can take that further. So let's go for a plus b to the power of 4. Now, using a similar method, that's going to be a plus b times our last result, which was a cubed, 2a squared b, 2ab squared, b cubed, giving us a to the 4, 2a cubed b, 2a squared b squared, ab cubed, a cubed b, 2a squared b squared, 2ab cubed, and then b to the power of 4. Again, adding down the diagonals again gives us a to the power of 4 plus 3a cubed b plus 4 a squared b squared plus 3 ab cubed plus b to the 4. Okay, what if we want to do a plus b to the power of 5? Well, we can look for some patterns in the results. Now, if you notice, a plus b squared, first term was a squared, first term a cubed, first term a to the 4. So in this one, I think it's a fairly safe assumption it's going to be a to the power 5. Then if we just look at the letters now, we've got ab, a squared b, a cubed b, so a to the 4b. Next one, ab squared. The next one here was a squared b squared. So if we look at the powers of a, it's going a to the 5, a to the 4, a to the 3, a to the 4, a to the 3, a to the 2, a to the 0, a to the 3, a squared, a to the 1, a to the 0. So a to the 5, a to the 4, a to the 3, a to the 2, a to the 1, a to the 0, which we don't bother writing down. If you're looking at b, b to the 0, b to the 1, b to the 2, b to the 3, b to the 4, b to the 1, b to the 2, b to the 3, b to the 4, b to the 5. So all that remains is to work out what the coefficients are. And there are a few ways of doing that. One way would be to use what's called Pascal's triangle. Okay, so let's look at the numbers that we had in our expansion before. So in a plus b to the power 1, we had coefficients, it was just a plus b, so we had coefficients of 1 and 1. A plus b squared was a squared plus 2ab plus b squared. So that went 1, 2, 1. A plus b cubed was a cubed plus 3a squared b plus 3ab squared plus b cubed. So it was 1, 3, 3, 1. And the next one went a to the power 4, 4a cubed b, 6a squared b squared, 4ab cubed b to the 4. There is a pattern in these numbers. If you look, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. So say now I wanted to do a plus b to the power 5. The coefficients would be 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and 1 on the end. So in terms of the terms, let's start off with a. So it would be a to the 5, a to the 4, a to the 3, a to the 2, a to the 1, a to the 0, b to the 0, b squared, b cubed, b to the 4, b to the 5. Put in the coefficients, 1, don't bother writing, 5, 10, 10, 5, 1. Again, just don't bother writing. So this is how we can expand brackets to quite large powers where they've got two terms. So let's now look at example 1 on page 159 in my textbook. So example 1. That has x plus 2y to the power of 3. Well, the first thing I'm going to do is look at what's the expansion for a plus b to the power of 3. Well, that was a cubed, a squared b, ab squared, b cubed. And using Pascal's triangle, just very quickly, 1, 2, 1, 1, 3, 3, 1. So power 2, power 3. So 1, 3, 3, 1. Now what we're going to do to go from here to here is use a simple substitution. We're going to simply say that a equal x and b equal 2y. That'll give us x plus 2y cubed equals, so everywhere I've got an I, I'll replace it with an x. Everywhere I've got a b, I'll replace it with a 2y. It's important that you put that in brackets because the powers also apply to the number in front of the y, the coefficient of y. So it's not 2y squared, it's 4y squared. It's not 2y cubed, it's 8y cubed. So simplifying all that gives me x cubed plus 3 times 2 is 6, 6x squared y. 3 times 2 squared, 3 times 4 is 12, 12xy squared. 2 cubed is 8. So x plus 2y cubed is x cubed, 6x squared y, 12xy squared plus 8y cubed. Okay, if we go on to b, which is expand 2x take away 5 to the power of 4. So again, what I need here firstly is a plus b to the power of 4. I mean, you can do a minus b to the power of 4 and can be slightly quicker, but we'll do it this way first. So Pascal's triangle, we need one more. 1, 4, 6, 4, 1. And look, there's some patterns you can start seeing here. So power 4, they'll always start with a 1. 1, 4, power 4. Power 3, 1, 3, and so on. If you look at the powers and the terms as well, just quickly, 2 plus 1 is 3, 1 plus 2 is 3, 3, 3. So when you add up the powers of x and y, they're always going to be the same as the overall power. So anyway, so it's going to be a to the 4, a to the 3, a to the 2, a to the 1, a to the 0, b to the 0, b to the 1, 3 plus 1 is 4, b to the 2, 2 plus 2 is 4, b to the 3, 1 plus 3 is 4, b to the 4. Numbers from Pascal's triangle, 1, 4, 6, 4, 1. Okay, I didn't need that last one, but there we go. Substitutions this time, I'm going to get a equal 2x and b equal minus 5. You're going to have to be careful here because of the powers. So make sure you put all the b's in brackets when you make this substitution. So 2x take away 5 to the power of 4 equals 2x in brackets to the power of 4 Now obviously you probably don't need a calculator to work these out, but there's no non-calculator exam anymore in A-level mathematics, so you can just smash all these into your calculator. 2 to the power of 4 is 16. And then here I've got 4 times 2 cubed times minus 5. So that's 8. 8 times 5 is 40. 160 minus 160x cubed. It's getting quite hard now. Now, minus squared is a positive, so this one's definitely going to be positive. You've got 4 times 25 is 100, times 6 is 600. This one, minus cubed, is negative, so overall it's going to be negative. 125, 250, 1,000, and 5 to the power of 4 is what, 625. Hopefully. Look at the pattern as well in the signs. Positive, negative, positive, negative, positive. So it's an easy pattern to spot there. Just checking against the answer, make sure I've manked it up. Oh no, I've managed to get it right. Well done, mate. Okay, example 2. Example 2. So it says the coefficient of x squared in the expansion of 2 minus cx cubed is 294. Find the possible values, it's using plural, there's probably more than one answer, of the constant c. Okay, so we know we're going to be looking for 294 x squared. Okay, so firstly, if I expand a plus b cubed, and we did that in the last example, so that was a cubed plus 3 a squared b plus 3 ab squared plus b cubed. So substitutions need to make this time a for a 2, b for a negative cx. So I don't actually need to do the whole expansion, but I will do, and you can spot the shortcuts you can make later. So that's 2 cubed plus 3 times 2 squared times negative cx plus 3 times 2 times negative cx squared plus negative cx cubed. Now in this question, we're only interested in the x squared part. Now if I look through this to see where the x squared is going to come from, well, it's here. So actually this is the bit I was only interested in. And if I simplify that, you'll see I'll get minus 6 c squared x squared. And what we were told was the coefficient of x squared is 294. So this is 294. Of course, minus c squared is positive, not negative. So we have 6c squared is 294. Divide both sides by 6. C squared is 49. So the tempting thing to put here is c is 7. But remember from the question it said values. So c equals plus or minus 7. Because minus 7 squared is obviously 49 as well. So that's all the content up to exercise 8a. So what you need to do now is go and smash exercise 8a. If you look through the email Mrs. Bick sent you, you'll see she sent you a link that gives you worked solutions to all of the questions on the exercises. So if you do get stuck, you can refer to those. Or if you email your maths teacher on a particular question you're stuck on, they can get back to you with a solution. Or I can do one of these video solutions for you. Okay, hope that was useful. Lesson 1 is done.